Namaskar, hello, and a very warm welcome to CIET NCERT's live phone-in interactive program. I'm Tanvi Khurana, and this is a science class for all the students studying in class 10th. And the topic being discussed is going to be electricity, and this is the second part of the same topic. If in case you have missed watching the earlier part, that is the part first, then please watch it on our YouTube channel, that is NCERT Official. Well, you can see on your screens, we have a sign language interpreter with us. Let me please welcome Sahib. Sahib is going to interpret each and every word getting discussed in this particular program, and this is going to be helpful for all the children. Apart from this, if you have any questions, any queries regarding this topic, electricity, please raise them. You can either call us on our number, that is 8800440559, or you can simply email us. The email ID would be dth.class10@ciet.nic.in. You're watching us on PM eVidya channel number 10 and also on our YouTube channel, that is NCERT Official. In the live chat box, raise your questions, queries till 4 o'clock, and our expert, he'll be more than happy to answer all the queries that you will be raising. So let me please introduce our guest to all of us. We have with us Mr. Bergin G. Sir, a very warm welcome to you.
Good evening to all.
Good evening, sir.
Session.
Sir, we'll begin this conversation very soon. Let me just introduce you to all our viewers. Sir is a PGT in Physics from Government Boys Higher Secondary School, Sayalgudi, Tamilnadu. So, I'm so sorry for interrupting you. Let me just ask you about the electricity part first. Just sum up the first part for our children to get a brief idea of what we did earlier, sir.
Yes, today's class we are going to discuss on the topic electricity. In the previous session also we already discussed on the topic electricity part 1. In that part we discuss on the topic what is current, how current is flowing from one point to another point, what is potential difference. So in such area different questions are discussed on that topic. So today's topic we are going to deal with the remaining, that is resistance, factors affecting resistance and power.
Okay, so let me ask you that would you like to please explain the concept of resistance in an electrical circuit?
Yes, I will explain through one activity. I am taking one simple electric circuit here,
okay,
with a battery and ammeter connected in series. There is a gap here, that is XY. I am taking three materials. One is nichrome, another one is torch bulb, and third one is 20 watts bulb. First, when I connect this nichrome with this circuit, some current is flowing through the circuit because circuit is closed. We don't know how much current is flowing through the circuit, but some current is flowing through the circuit. Now I replace the nichrome wire with the torch bulb. What happens? Now the bulb gets glow, the current is flowing, but not the same current of the previous one. Here it is different, current is different. In the similar way, when I connect this 20 watts bulb also, the bulb glows, there is a current flowing through the circuit. The ammeter also shows some reading, but in three cases, the ammeter shows different reading. Why? Because these three materials allow different current in different material. For example, when I connect nichrome is a highly resistive material. That means it resists the flow of charge. So if it resists more charge, that means it will allow less current. When I am taking the torch bulb and the 20 watts bulb, torch bulb needs only few current. When compared these two, the resistance of the bulb is more in torch than in 20 watts bulb. So in comparison, I can say that the current flow through the nichrome is less than the current flow through the torch, which is less than the current flowing through the 20 watts. This is because of the property called resistance. Here the resistance of the nichrome is greater than the resistance of torch is greater than the resistance of 20 watts. I will explain this with one small animation. Here I am taking two material, one is iron and another one is copper. When iron is connected with a battery, current is flowing through the circuit. So current means flow of charge. So when charge is flowing through the iron, it will collide on the atoms and ion present inside the iron. In the same way, in copper also the charges collides with the atoms and ions. Now compare these two. The collision is more on iron than in copper. Collision more means resistance is more. More resistance means it has high resistivity. So in the two cases, iron has more resistance than copper. That we called as a resistance of a material. More resistance means it will resist more the current. So in the case of iron and copper, iron has more resistance because it collides more. In the same way, every material has some resistance, and we can call this property as a resistance.
Okay. So can you tell us what are the factors that affect the resistance of a conductor?
Yes, I explained what is resistance, but some factors are also affecting the resistance. For example, one of the factors is length. I am taking two wires, one with a shorter length and another one with a longer length. In shorter length, the collision distance is very small when compared with the longer one. So even though there is collision, it can come within a limited distance it can cross. So the resistance is less. If the same material is taken and if the length is long, it has to collide with a longer time. Longer time means the resistance will increases. So length increases, resistance also increases. So length is one of the factors that affect the resistance. Then another factor is area. If you take one material with two dimension, one with a less thickness and another with some wider one, the collision is greater in small thickness and the collision is less in wider one. So as area of cross section increases, the collision decreases. So we can say this resistance is inversely proportional to area of cross section. As area of cross section increases, the resistance decreases. By combining these two, we can say that resistance is proportional to length and inversely proportional to area. If you remove this proportionality, there is another factor plays, that is called resistivity. This resistivity is that material dependence. Each material has some resistivity. According to this, the resistance changes. Therefore, at constant temperature, these are the three factors affecting the resistance. But when the temperature increases, the atoms and ions present inside the conductor will get more vibrated because it gets the energy and gets vibrated. So the probability of hitting the ions is more. More hitting means more resistance. So for a conductor, as temperature increases, the resistance increases. So altogether, the temperature depends on 4 factors. To explain this, I am taking two material A and B. Material A and B are connected in a circuit and we measure the current and voltage and we get the graph like this. A and B are the two graphs getting from these two material. As current varies, we measure voltage, we will get this graph. The question is, which one has more resistivity? So as we know, the resistance means the slope of the curve will give the resistance because slope means change in y by change in x. Here change in y is voltage. Change in voltage by change in current is nothing but resistance. So the resistance can be written as rho into L by A. Since both materials are having same length and area, the resistivity only depends on the resistance of the material is only depends on the resistivity. So comparing the slope, more steep, more slope. So A metal has more resistivity than B metal. So in such a way, the graphical solution can also done in case of resistance. So we can say that rho of A is greater than rho of B. I will explain the resistivity in some other problem. Using this problem also, here three geometrical shapes are given with the same material. Material first shape has area of cross section A and length L, and second one with area A by 3 and length 3L, and third one with area 3A and length L by 3. Let us calculate the resistance of these three materials. For the first material, we can directly write rho into L by A as I explained in the previous slide. In the second case, the area is A by 3, length is 3L. So in the place of area, I will put A by 3, and in the place of length, I will put 3L. So it can be written as rho into 3L by A by 3. Now these 3 can be taken up. So we can write 9 rho L by A. So when comparing with the first case, we can say that RB is 9 times RA. In the similar way, if we calculate the resistance of the third shape, it is coming as 1 by 9th of the first case. So if you compare these three, the resistance of the second one, that is RB is greater than RA, which is greater than RC. So in such a way that the different factors affecting resistance can be related using the formula R is equal to rho L by A. With the help of this formula, you can solve n number of problems. So if such problems are asked in the exam also, you can do if you understand this concept properly.
Okay. So going further, if we see a typical house or a building, we see the electrical wiring in there, they are connected in parallel rather than in a proper series, in a proper ordered symmetrical series. Why is this the case?
Yes, normally if you know the answer for that, we have to know the difference between serial and parallel. If resistance are connected in series, that means the current flowing through the circuit is same and the voltage is different. So if three resistors are connected, the total voltage is V1 plus V2 plus V3. In the place of voltage, we apply, if you apply Ohm's law, we will get IR equal to IR1 plus IR1, IR2 plus IR3, because the voltage across V1 is I into R1, voltage across V2 is I into R2, voltage across V3 is I into R3. If you cancel all these R, if you cancel all this I, we will get R equal to R1 plus R2 plus R3. So the total resistance will increase if they are connected in series. And also another thing is, if it is connected in series, if you cut one of the resistance, the total circuit is switched off. But in the second case, if it is parallel, the current is constant, the voltage is constant throughout the resistance. I is divided into I1, I2 and I3. The total current I is equal to I1 plus I2 plus I3. Now if you apply Ohm's law here, we will get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now look at this relation. If you increase the number of resistance in parallel, then the net effective resistance will be decreases. And another thing is, if any one of the network is, if any one of the resistance is switched off, automatically the other will works. So in the case of bulb, I took 3 bulbs here connected in series and connected with battery. When the switch is on, the bulb will glow. But if any one of the switch is gone, the circuit will be off. But in the case of parallel, if there are 3 bulbs connected in parallel, if any one of the bulb is disconnected, other bulb works. In home, we are not going to use all the appliances at the same time. We are using fan one time, bulb another time. So if you off one of the device, other should be work. So in this case, it is better to connect as a parallel circuit. That's only we are using as a parallel circuit. But we have to think one of the things. We should not connect parallel all the appliances or more appliances in one point, because if you connect all the appliances or more than some 4 or 5 appliances in one point on a single point, the total resistance will be 1 by R equal to 1 by R1, 1 by R1 plus 1 by R2 plus 1 by R3, etc. So if too many appliances are connected in parallel and connected to a single point, the net effective resistance will be very less. So more current will be flow through the appliance. So there is a possibility of the damage of the appliance. So we have to careful when more number of devices are connected to a single point. Even though the devices that we are used in the home or circuit we are using in the home is parallel, we have to careful to connect to a single point. That's only different points are kept in our home.
Okay, sir, but this was not the case earlier. The older serial lights were often seen as connected in a series rather than in parallel. So if the older ones were connected in series, why not today? The newer ones are all in parallel. Why is this the difference?
Yes, it is a nice question. In the olden days, when serial lights are connected, if any one of the bulb is gone, automatically everything off. No bulb is glowing. But nowadays, if one or two bulbs are also, if one or two bulbs damaged, then there is nothing happen. Remaining bulb will glow. What happens here, I will explain. Here, if you connect it with a series, then the total voltage given is divided into two bulbs and the bulb will glow. And also if it is parallel, it will connect like this. In parallel, if any one of the bulb is damaged, the other bulb works. Now look at our case. Let us take 15 volt battery. So this 15 volt battery is divided into 3, that is 5 volt each, and each bulb we can use 5 volt bulb 3 and connected in series and connected with the battery 15 volt. In our home there are 230 volts. If there are 10 bulbs, we can use some 23 volt bulb 10 connected in series, and we can connect with, to the main plug, so that each bulb has get 23 volt. But nowadays they are connecting in parallel, and one change they will do, because suppose if the same bulb is used here, the voltage across the bulb is 5 volt. If you give 5 volt, then only it will works. If you give more than some 200 volt here, the bulb will burn. So instead of giving the whole voltage, now we are giving 5 volt only, because all the voltage across the bulb will be same. So when new serial bulbs are constructed in such a way that they are connected in parallel, and the voltage is voltage is reduced, and according to the bulb they are providing voltage with a circuit board. That's only nowadays serial bulbs are working, even though 1 or 2 bulbs are damaged.
Okay. So we don't have much time left, so I'll ask the last question, and I would request you to just answer it in brief. So why does a bulb's filament heat up significantly more than the connecting wires when the same current flows through both?
Okay, it is also an interesting question.
Yeah.
For that, you have to know how the heat is produced when current is flowing through the wire. When a current is flowing through the wire, the electrons are hit on the atoms and ions present inside the material. so that that ions get energy and gets vibrated, and so it is get heated. The heat energy released is I square RT. That means the current I square, R is the resistance and T is the time. Now the question is, the same current is flowing through the wire and the bulb. But bulb gets heated, why the wire is not heated? That is the question. Even though the same current is flowing, the resistance used in that bulb, that is the filament resistance, is very high when compared with the wire. So when we compare these two, the resistance of the bulb is much greater than the resistance of the wire. So the heat generated is I square RT. I is same for both cases and T is also same for both cases. Therefore, heat energy developed is only depends on the factor resistance. Since the filament has more resistance, more heat is generated on the filament. I hope you and I answered that question.
Yes, sir, absolutely, you did. Thank you so much for being with us today. It was a wonderful conversation indeed, and thank you for being with us, for giving us your time.
Okay, ma'am. Thank you.
Thank you.
Was also ready to answer many questions, but time is limited. So
Yeah.
I would meet you in some other session.
Absolutely, sir. Thank you once again. Thank you to our viewers as well for being with us today. I really hope that you enjoyed this conversation, and I would also like to thank our sign language interpreter, Sahib. Thank you for interpreting each and every word being discussed in this program. So we have a series of programs lined up for the day. Let me just give you a brief schedule. You can see it on your screens. The next program that you are going to watch is our series, and the topic is going to be Samachar Saksharta for class 6 to class 12, followed by another program of ours that is from 5 to 5:30. Sahyog series will be there. The topic will be Gratitude, the Secret of Happiness. And lastly, from 5:30 to 6:15 for classes 6, 9 and 12, our series of NCSL NEPA will be there. The topic will be Role Modeling for School Improvement, Leading a Government Middle School in Tribe Dominated Area in Assam. And with this, we are wrapping up our this particular program, but let me also tell you that if you have not purchased the class 4 and class 7 textbooks till now, you can also buy them from Amazon, Flipkart and of course on our NCERT officials website. So please purchase them if you need them. Thank you so much once again. Have a great day ahead. I'm Tanvi Khurana and I'll take a leave of you. Namaskar.